Hello guys and welcome. In this video, we want to see how do we effectively use the SafetyNet Attestation API in a real Android application. In the previous video, we described what the SafetyNet Attestation was all about and what are the specificity of this API, in what scenario or in what case do we have to use this API. So if you've not watched this video, I will invite you to check the previous video in order to have more information on the SafetyNet Attestation API. But before moving forward, I want to emphasize on some points which I think are necessary for you to better understand what the SafetyNet is all about. The SafetyNet actually is a set of APIs, among which the SafetyNet Attestation API. So you can see it on my screen. You have the SafetyNet Attestation API to check the device integrity, and you have the browsing API to check if if a particular URL you are about to open is actually genuine and it has not been marked as a threat. And you have the reCAPTCHA API for your reCAPTCHA purposes, and you have the verify apps API. This is used in case you want to check if a particular app running on a device is harmful or not, right? So I just wanted to point out that the SafetyNet is made up of several APIs, but for this video we're talking about the SafetyNet Attestation API. So let's move forward. And it's actually used to avoid situations where your app is used by an emulator, or to avoid any form of compromisation which you think may be harmful to your application, right? And before we dive into the code, I would just want to point out that the SafetyNet Attestation API by default, it has a limitation of 10,000 requests per project per day. So if you have more than 10,000 users launching this request in a particular day, then you may have an error, right? In this case, you have to request for a higher quota. And another thing to point out is that for a particular user, you cannot do more than 5 requests per minute. So a recommendation I pointed out in the previous video, in order to avoid you running out of your 10,000 request quota, is to run this request just the first time a user launches your application, right? So if you run this request just the first time a user launches your application, just to check if this user running your application is genuine or not, then you will not have to fall in this situation where you need to request for a higher quota from Google, right? If for you to request this quota from Google, then that means you should have more than 10,000 new users per day. But if it's not the case, then you can just launch this request just the first time a user launches your application, and you can have a flag which you save in the shared preferences, in the private shared preferences of your application, and in the next launch you can just check this flag and find out if this request, if the device has already been checked or not. If the device has been checked, you can just get the result and find out if the device has been checked positively or negatively. That is, positively means that the device matches, the device integrity is okay, and negatively means that this device integrity has some issues. And if now this device have not yet been checked, then you can launch the SafetyNet Attestation request to verify the integrity of the device. So that's an advice which I think you can do in order to avoid the situation where you need to request for higher quota from Google. So that being said, let's move into the code and see how do we use this attestation API. It's a very good API, I like it. So the first thing to do to use this API is to request for a key. And to do that, we have to go to the library page of the Google API console by clicking on this. I will leave the link in the comment section below so that you can easily go to this page. So once you are here, you can just type in the Android device verification API and submit, and you will see the Android device verification API. You click on it, and here you are. For your particular project, if this is not yet enabled, you will see the enable button right here. But if this is already enabled, you can just see you will see the manage button. So you can select here the project for which you want to enable this API. For me, I will just select this first project and I will click on manage because I've already enabled this API. And you can go to credentials and you have the keys. If you don't yet have a key for your project, you can create a credential, or you can delete the existing one by selecting here and click on delete, or you can create a new credential for your project. I don't want to create a new credential, I already have one. You can just click here to copy. Once this is done, I will go to my project, right? Go to my project and I have a config class where I can paste in my key here. You can go into your project and paste or save your key wherever you want. For me, I save it in a config class. I usually have a config class for my project. The next thing to do is to go to the build.gradle and add the dependency for the SafetyNet. This at the current time of recording of this video, the most recent version is the 17.0.1. The next thing to do is to add this dependency and build your project, right? So once this is done, let's move now to the main activity to actually find out how do we use this API, right? Here we are in the main activity, and this is the onCreate method. And as I said in the previous video, the SafetyNet Attestation API or the SafetyNet APIs depend on the Google Play services. So we have to make sure that the Google Play API is available on the device we are about to run this API on, right? So we first need to check if the Google Play API is available on this device, right? And to do that, we check by running this code. We get the Google Play API availability instance, and we check if Google Play services is available on this device. If it's available on this device, we will have a result of success. Otherwise, if we don't have result success, then we have to check if we can solve the error by doing a user action. That is, if we can solve the error by the user doing an action, maybe by updating the Google Play services or by doing any other action. If it's the case, then we run this. If it's not the case, then you cannot run the SafetyNet attestation on that device. Once we check and verify that the Google Play service is available on the device, then we can go forward and run the SafetyNet attestation API. So I created a function called send SafetyNet request, and in this function I'm calling the SafetyNet library. Alright, I'm calling the SafetyNet library gotten from the dependency we added to our build.gradle. So this is how we call the library, SafetyNet.getClient. We pass the context and we call the attest method, right? The attest method takes in two parameters. The first parameter is the nonce. The nonce is just a byte. It's just an array of byte which we created. We created this array of byte using the system time, because we want that each time the nonce should be different, and it's our way to create a unique nonce each time we request for the nonce. Create a nonce which is a series of bytes or an array of bytes, and we also pass the API key. The API key, as you remember, this is gotten in the previous step. This is the API key. So we call the attest method of our SafetyNet client, and If this is successful, we will have a result in the unsuccess listing, and we will have a result in this callback method. And the result is simply a JSON web token, right? The result is simply a JSON web token in a string format. Let's say that way. The result is simply a string, and this string is actually a JSON web token. So once we get this result, we need to verify if this string is actually genuine, because this string can be inserted into your application by a hacker that want to steal some information, or that want to bypass these verification procedures. And to do that, we need to call another method. Actually, just to point out, just to say this clearly, if our application was making use of a backend, the recommended way by Google is to verify this string from your backend. That is to send this result to your backend and do the verification on your backend. That is more secure way. That's a more secure way to verify the result of the attest method, right? But if we don't have a backend, Google provides us with an endpoint which we can use it. So that's why in my case, since this application does not make use of any backend, I can pass the result, this string result, this string, which is a JSON web token. I can pass this result to another function I created, as you can see in here. I will pass this result to this function and do the verification at this level, right? And to do this verification, I created an API using retrofit. I'm sure you've heard about retrofit. I think retrofit is the most popular HTTP API, HTTP library on Android. And this is not a retrofit video, but I just want to show you what I did. I created a retrofit API using this base URL, the googleapi.com, and this is the endpoint we actually have to send a request to verify the results we have. We need to send a request to this endpoint, and this endpoint actually takes two parameters. The first one is the key that was gotten from our project online, from the Google Console library page. And we also need to send the body of this request should be a verification, should be just an object made up of the signed attestation. This object is just made up of the signed attestation. The signed attestation is just a string that was generated from the SafetyNet library, right? It is just a string that was generated from the SafetyNet library. And I will show you how we created this verification request. Just 1 minute, you will see it. So I just wanted to show you how I created my API with a retrofit. So you can drop comment section below if you want me to do a video on retrofit to show you more information on how to use retrofit. But this video is not on retrofit, so I was just showing you how I created a retrofit API. And now we pass in the sign attestation statement. You remember, this sign attestation statement is just this JSON web token string that was generated in the previous step. That was generated from our SafetyNet client. So this is it. So once we have our JSON web token string, we create a verification request. As I told you before, the verification request is simply an object having this property, sign attestation. You can call it you can give it any name. You can give this object any name, but I decided to call it verification request. But this property should be in your object, right? This property is very important. So we created our verification request from this string, and now we send the request to the Google API servers, and if all is okay, we will have the response in this callback method. And in case of any issue, we will have a failure response from this callback method on failure. But if the request is successful, we will have our response in this callback method. The response will come with an object called the verification response. Also, this verification response is just an object I created to be able to pass the response, right? I created an object called verification response, and this object has a particular property. This property is a boolean and it's called is valid signature. Actually, this property is used to be able to attest that the signature sent to the Google API server is valid or not. So once we are sure that the signature is valid, then we can pass the JSON Web Token. We can pass the JSON Web Token string in order to get a JSON Web Token object. And to do that, I use a library. Let me show you. To do that, I use this library. This library is useful to be able to pass a JSON Web Token string to a JSON Web Token object. So I use that library. This is it here, and I pass my string to get a JSON Web Token object. And from this object, I was able to get the payload. Remember, it's the payload that is important because it's the payload that contains the information we want to extract. So you get the payload, and from this payload, I was able to create an attestation statement. And attestation statement is also an object which I created in order to ease the usage of our results. Remember that the SafetyNet Attestation API gives you a JSON Web Token string which contains a payload, and this payload has these properties, right? This payload has these properties. That is the timestamp. The timestamp contains the time when the request was sent to the Google. The request was sent to the SafetyNet client, and you have the package name, just the package name of the Android application which created the request, and you have the APK certification digest. I've explained all of this in the previous video. So, and you have the CTS profile match. This is very important because the CTS profile match is actually this property which is able to check if this device matches the compatibility test suite profile, right? If the device matches the compatibility test suite, and I said in the previous video, the compatibility test suite is actually a set of properties that describe a particular device, right? A set of properties that describe a particular device model. And if your device matches this CTS profile match, then the integrity of your device is okay, and you have the basic integrity too. So these are the properties you have in the payload of the JSON Web Token string, and we're able to create an object that will be used to pass this payload to get these properties, right? And this is how we do. We use the JSON library to be able to convert the payload string. We get the payload, we convert this payload to JSON web to a JSON object, and we convert this JSON object to a string. And now we use the JSON library to be able to convert this string to an object, to an attestation object, and this is the object we are interested in. So once we have this object, we can now send this object to any function, or we can now check the properties of this object to be able to attest if the device running our application is okay or not. So what I did is that I got this object and I sent this object to this particular function I created, and in this function I now check this property. To find out if this device, if the CTS profile match is okay or not. So for simplicity, I just send this text. To our text view to be able to tell if our device integrity is okay or not. So in your case, it depends on what you want to do. You can decide that if this is not, if the CTS property is not okay, you can decide to close your application. That is, you want to prevent this device to run your application, or you can decide to do anything you want. But just for simplicity purpose, I decided to display the text. Since we're just testing, I just decided to display the text, so to be able to say if the device integrity is okay or not. So that is it, and you can check the link to the code to have more information, or you can pause the video, or you can rewind the video if there's anything you've not gotten clearly. I will leave the link to the video in the comment section below. So now we can run our application and find out if this application runs properly or not.